In this video, we will use our magnetic molecular models to illustrate 6 functional groups that combine carbon, oxygen, and hydrogen to form compounds important to both organic chemistry and biochemistry. In addition to the sp3 carbon used for alkanes, we will also use a 3-hole sp2 carbon. A smaller oxygen is used in combination with the sp2 carbon to denote the smaller radius of the doubly bonded carbonyl group, compared to a singly bonded oxygen to a 4-coordinate carbon. This is similar to a single bonded carbon-carbon versus double bonded carbon-carbon, where the covalent radius of the double bonded pair is shorter. The simplest functional group is alcohol. Here we make an OH group by using the 2-coordinate oxygen with a hydrogen atom. To make the simplest alcohol, we add this to a methyl group, which gives us methanol, also known as wood alcohol. Add another carbon to get ethanol, and then a 3rd carbon, which gives us N or 1-propanol. If you move the OH group to the middle carbon, you make a secondary alcohol called isopropyl alcohol, commonly known as rubbing alcohol. This is the simplest secondary alcohol that can be made. A basic ether is simply an oxygen that bonds and forms a bridge between 2 carbons. Here we use a 2-coordinate oxygen to make this bridge. We add 2 methyl groups to make the simplest ether called dimethyl ether. Dimethyl ether is a common aerosol propellant. If you add a 2nd methyl group, you make methyl ethyl ether, and so on, extending the carbon change as needed. To show aldehydes, we now use our sp2 carbon bonded to the smaller oxygen. The simplest of these is methanol. An aldehyde group contains carbon double bonded to oxygen and an H-terminal group. The common name for methanol is formaldehyde. If we remove the hydrogen and add a methyl group, we get ethanol, and then a 3rd methyl will give us propanol. To form a ketone, we start with the same carbonyl group as the aldehyde. A ketone has a carbonyl group bonded to 2 R groups. The simplest ketone is propanone, which also has the common name of acetone. To make a carboxylic acid, we again start with a carbonyl, but now we add an alcohol group. This is the basis of a carboxylic acid. The simplest carboxylic acid is methanoic acid. If you take the hydrogen away and put a methyl in its place, you get ethanoic acid. Add a methyl to ethanoic acid and you get propanoic acid. For esters, we begin with a carboxylate group. The difference between the carboxylic acid group and the carboxylate group is that the hydrogen is removed. In place of the hydrogen, you add a methyl group, or chain of carbons. In this instance, the simplest ester is made. We can extend the chain further with additional R groups at either end to produce many common fragrance-based compounds. Here are some takeaway thoughts for you, the viewer, to answer. Propanone contains 3 carbons and is the simplest ketone. Propanoic acid also contains 3 carbons. If the common name of propanone is acetone, why is the common name of propanoic acid not acetic acid?